This is an introduction to Project 2 for Data 301. And so now I'm going to share my screen so you can see project itself. Here's Project 2. It's due at midnight on the 26th. Here's the GitLab repo. And here is all the stuff associated with the project. So I'll start with the README here. The purpose of this is to figure out how to do clustering on a data set. Now, I've given you a data set, and the data set is right here, this marketing campaign. It has 800 and some plus entries in it. And we'll talk about it in a second. So it has 861 rows, and you have 29 columns. If you want to see what each column means, you can look at this project 2 description.pdf. So if you open this, it tells you the purpose of every single column in here. So all of these accepted comp columns, those are if a customer has accepted some sort of offer that was sent from the company. This is basically you sent the customer a coupon, did they use it? And there's a bunch of other fields in there as well. This is going to be your key to figure out what the fields mean. One that's important is this complain column. This is whether the customer has complained in the last 2 years. A bunch of other things. Education, that's going to be important because you're trying to segment customers and figure out who's going to buy what. Education is probably going to be directly proportional to income. Also, marital status and whether you have kids at home, that's going to be directly proportional to how much you spend at the store, because the more kids you have, the more you're going to buy. There's income, and then there's the amount of products that they buy, and this recency, the number of days since they last made a purchase. So it's tracking a good bit about their customers. And so if you go to the data set and open it up, there's a ton of columns here. And then you can see the first part of it. One of them is the year of birth. You can translate this directly to how old somebody is very easily. Like I should basically take this year, 2024 minus 1954, and that's going to give you an age for this person. Education, that's going to be a little more iffy. The education is not, you might want to sort on this column or actually get a value counts and to see what this is, because I don't think it's not the sort of things that you think about. For instance, there's something called a second cycle. You have to figure out what that is. Is that better than graduating from high school? Is that a PhD? Is it a master's? What's graduation? Is that graduation from high school? How do you rank these things? Because these educations, I mean, it's clearly an ordinal column, but how do you organize these? Marital status is also going to be a little complex because people were not provided with a bunch of categories. They were able to just fill this in. And so you're going to find some funkiness inside of here, like alone. That basically should have been single. Then you have a bunch of incomes. Notice that you're missing some incomes. You have to impute those. This is going to track whether they have people at home. And this date time customer is when they first became a customer, when they last visited. And now we're going to track how much stuff they bought. If you go over here, you can go all the way down to the bottom of this, all 860 rows. And then you can scoot over and you can see all these columns here. And see what all this stuff is. And this just tracks what they purchased there. And so, as I said earlier, there are, in the introduction, there are 861 rows with 29 columns. This is going to describe what each column is. So what I want you to do is take this notebook here, which we're about to go to, and it's right there. And I want you to do everything that's inside of the notebook. There's a lot of to-dos in there, and I want you to complete those to-dos. Now, some of those to-dos are questions for you to answer, but there's some other requirements. I don't want you to use any for or while loops. I want you to use the vectorized operations that are built into Pandas. Use only map and apply on all of your operations. No for loops, please. I want you to impute all the missing incomes. Don't use the average over the entire column. That's too easy. I want you to do something that's a little smarter to impute the incomes, something like what I've been doing in class. Reduce the number of features. Well, you can use PCA. You can combine columns like the amount of products that are purchased if you want to, but sometimes the amount of products purchased is by particular category. Is it a good idea to combine those columns? Make your choice and tell me why in the notebook. Drop any columns that provide no information, basically no variance columns. Convert the dates to a format that's going to be suitable for an algorithm that uses Euclidean distance as a metric. Right now, if you look at the dates for things like year of birth, it's, well, 1954, 2011. It's not as useful for distance. Any other date that you have inside of this marketing campaign, like date of last visit here, this is not as useful for especially this one is pretty easy to convert to a number to give you an age. This one is not. You want to convert this date to something that you could use the Euclidean distance. And essentially, this is the date time that they were last in. You want to convert this to probably not the last, how many years ago they came in, how many months ago they came in, maybe a good, well, it might be a good metric. So keep going down here. Fix any obvious outliers. There's going to be a couple. Run PCA on the remaining columns. I mean, if you want, you can run UMAP too as well to see what you get. And cluster the data using k-means and HDB scan. So I've given you an example. I think today the notebook that I went over used both k-means and HDB scan. Make sure you pick, for k-means, I've given you some algorithms to determine the number of clusters, specifically the silhouette score. So for both of them, use silhouette score to see what the right number of clusters is. HDB scan is a little harder to tune the parameters, but it converges pretty quickly. And there's only 861 rows. So you can play around with the parameters of HDB scan, much like I did today. And oops, sorry, it tried to hang up on me. Much like I did today to try to get an HDB scan to converge to a decent answer. Do all the to-dos in the provided notebook. And once you're finished, you're going to have basically this marketing campaign with a bunch of clustered rows. Try to interpret what those rows mean. I gave you some tools for doing that today and during the last class. You can use an SNS pair plot to look at what the clusters mean. You could use also group by to see what each cluster, see some summary statistics for each cluster. And mostly, you're doing this to see if the clustering algorithm will give you some results that cleanly separate these people. And if you look at this, you might think, well, why should I bother with 861 rows? For 861 rows, you can probably just use UMAP. For 861 rows, you can probably do it by hand. But for 861,000 rows, you can't. That's why you need these algorithms. Try to figure out what the clusters mean. I think it's going to be helpful. And I think one of the clusters that is going to show up is that complaint column. So it turns out that people who complain are, you may find that they're special in terms of clustering. So we've got some boilerplate here. Load the data. Let's see, a bunch of helpers. Load the data, the marketing campaign. So once you sync to this repo, the marketing campaign will be there. You'll be able to pull it in. You get a little bit of information about the number of data points. Here's some things that might be useful to you throughout your exploration. Then I want you to clean your data following all of these to-dos. Notice this bit here. Tell me why you chose them. Combining which features. If you're going to combine features, tell me why. I want to know what your thought process is behind it. Okay, handle all the categoricals, both ordinal and nominal. Examine marital status. Yeah, you're going to have to combine some of them because marital status probably doesn't have as many unique values as what shows up in this table. So you're going to have to combine them somehow. So show me the code that you use for that. Show me your functions that do this. as well. Uh, Um, convert date time customer, the number of months this person has been a customer. Right now, DT customer is date time, month, day, year. Convert it to the number of months they've been a customer. And also, you're going to notice that there's going to be a skew in these date times because this data set is old. So the date time, all the customers are going to be from a while ago. I think in 20 teens. Year of birth, convert the person's age in years. Convert the year of birth to their age in years. I showed you how to do this in the notebook today. And then there's a bunch of missing incomes. So what you should do is, if there are any outlier incomes, set them to NP, to not a number. And then in the next one, I want you to impute all the missing income. So up here, you take all the bogus incomes, all the missing incomes, set them to NANs. And here you're going to impute them. And I want you to use a group by over at least 2 columns in the data set to find a mean income for those missing incomes. Anyway, you'll use that as a lookup table to find the missing incomes. And if you're going to use age as one of those columns that you group by over, make sure you bin those ages because there's a lot of ages. Then get rid of any duplicate rows and low variance columns, and that should be pretty straightforward. The ID column you're going to find is probably not as useful because it's too high variance. There's as many unique IDs as there are rows, so it's not really there's no information there. And then people who complain. So I want you to, what percentage of the people grouped by education complain? So what have I got down here? Plot the total purchases. Another 5-pointer here. Plot the total purchases all users have made. All the columns starting with the amount prefix against their income, and use a scatter plot for this. And use the values of 1 and 0.1 for the alpha. And what this is going to do is when you plot the scatter plot, it's going to draw the points so that they're transparent. So that way, if some points are lumped on top of each other, you'll be able to see density of points. It's going to help a lot. I'll show you this next week. On the same figure, exact same figure, plot the total purchases all users who complained have made against their income and make their complaining users green. Based on this data, I want to know what the likelihood that people who complain will stop shopping at the store. Is it worth trying to even get them to stay? So I want you to answer this questions, and I want you to answer this question based on what these graphics show you. All right, and from that, run PCA on a data set. You can use UMAP if you want. I'm capturing 95% of the variance in the data, which means that I'm probably not going to lose many features. And then I want you to tell me what explained variance ratio means for PCA. So you have to run PCA. If you want to run UMAP, you're running it in addition to PCA. And now your data is ready. Now you can cluster it. How are you going to find the right number of clusters? So, by the way, you want to fit on either the principal component and components calculated above or the UMAP features calculate if you choose to do that. Use the silhouette score to choose the right number of clusters. Okay, and use a minimum of 3 clusters. The highest silhouette score is going to be probably the lowest number of clusters, so you don't want that. And once you've determined the number of clusters to use, run k-means and then run HDB scan. And HDB scan now is part of scikit-learn, so you can either install it separately or you can just use the scikit-learn implementation. And there's a 3D plotter that's part of utilities. If you want, you can use that 3D plotter to plot your clusters. And this is plotting my clusters based on my principal components. Or you can just use a 2D scatter plot. It's up to you. And do the same thing with HDB scan. Oh wow, this I have 2 to-dos here. Run k-means with a number of clusters determined above. Save predictions in the column cluster guess k-means, and use the plot 3D function and display helper in the utils package to show a 3D plot of principal components 1, 2, and 3, and for a data set. Set the hue of the cluster to cluster guess k-means. And for HDB scan, you kind of do the exact same thing. There's 10 points down here. Set the hue of the cluster to cluster guess HDB in this case, as opposed to cluster guess k-means. And then tell me what the clusters mean. And that's kind of it for the project. It's very much a straightforward application of what we went over today for 6-4 class cluster examples. And so that's it. If you have any questions, you can stop by office hours or you can shoot me an email. Let me know if and you're going to be using utilities package as well. The utilities package is, it's on the website. You can go and get it. It's, where? Somewhere here. Here, turn utils into a package. And it's right there, the new utils package. This should be right there. If you want to get it, take this, install it, and run it. And that's it. That's your project. And with that, I think I'm done.